In today's video, we are going to continue talking about vectors. We've talked about the fact that a vector is a directed distance. We've talked about the distance being the magnitude or the length of the vector. And today, in this video, I'm going to talk about the direction of the angle or the direction of the vector. So when we're talking about direction, we're not talking about north, south, east, west. We want an actual very specific degree measure or radian. We're going to be focusing on degrees here, but an actual degree measure of where this vector is pointing to. So the definition of direction angle is the angle of the vector in standard position. So this is just, if you remember, the angle formed by the positive x-axis and the vector. So when you plot your vector on delta math, okay, you can plot it just like I did here, and then they're going to actually have you move it to the origin. Now, I want you to notice when I move this vector, the components don't change. So the width of this, the height of this, the length of the vector, none of these things change. You're just simply moving this vector to a different spot on the graph. Then it just allows you to see the direction angle a little bit better here. So the direction angle is going to be formed by the x-axis and the vector. So this is the angle that we're looking for and finding when we talk about a vector's direction. So a few things when you're doing this, you can have an answer in your head, okay? You can have an idea of what you think the angle is going to be, because if it's in the first quadrant, you know that these angles are between 0 degrees and 90 degrees. We're mainly going to be focusing on degrees, not radians here. So first quadrant, if it's pointing here, you know your answer is between 0 and 90. Second quadrant, like ours, is going to be between 90 degrees and 180 degrees. And then third quadrant will be between 180 degrees and 270 degrees. Fourth quadrant between 270 and 360. This will allow you to kind of decide if you have any mistakes or if your answer makes sense if you just stop and think about that for a couple seconds before you start going with your problem. Now, why would you come up with answers that don't make sense in the situation? Well, because the reason that the way we're gonna be finding these angles is by using the tangent function. So we're going to be doing a tan inverse because we're actually going to look for the reference angle here. Okay, so this little angle in this right triangle. And the reason we're using tangent is we have the opposite side and the adjacent side, or the y value and the x value here. And we can just do the tan inverse function. Now, tan inverse just creates just a couple little issues, because just like every trig inverse function, it has a restricted domain. So tangent is only going to be able to kick back, our calculator is only going to be able to kick back values between negative 90 degrees and 90 degrees. So the only one that it's really going to be exact for is the first quadrant. If it's in a different quadrant, we're going to have to deal with figuring out that angle. And so we'll talk about that in this example that we're doing to help you figure that out. Then another thing, okay, so let's talk about the component form here. So you know the component form just from this picture. So it's pretty easy in this picture to see the component form because we've got negative 6, 8. Okay, let's remember back to the other video where we found the magnitude of this vector. So remember that the magnitude of this, just did Pythagorean theorem quick, and we got 10 here. So what if you're not given the component form? What if you're only given the magnitude and the direction angle? You can actually come up with this component form by following this formula here. And this one just has you do the magnitude. Okay, so the magnitude times the cosine of the angle. Cosine goes with the x, so that's why it's first. So finding the x would be the magnitude times cosine of the angle, magnitude times sine of the angle. So we're going to actually check back with this. for this example to see once we do actually find the direction angle, are we going to get back these components just to check ourselves. So let's go ahead and do this example. I'm going to move this again, okay, right to the origin. And then we're going to go ahead and find the direction angle using that formula. So we're going to do tan inverse of y over x. Okay, so tan inverse, and this is going to help us find the reference angle. So our y component is 8, our x component is -6. I'm going to go ahead and type that into your calculator. So we'll do 8 divided by -6, and then do the tan inverse. Make sure you're in degree mode for this. And we get 53.13. I'm just going to go to the nearest degree for this. So we're going to get our reference angle of -53. Oops, I was going to do nearest degree. Okay, so -53 degrees for this. So this is the size of this angle right here, right? So this is 53 degrees. Okay, it's kicking back this -53, but these two are exactly the same. So -53 or this reference angle of 53. So now obviously 53 and -53 is not our direction, because we know that our angle is between 90 degrees and 180 degrees because it, 180 degrees because it is in the second quadrant. So we just have to deal with that. So if this is 53 degrees, you got kind of two options. You can take 180 and just subtract 53 off of it, right, to go backwards. So it's not 180, it's 53 degrees before 180 to get 127 degrees. Okay, that's one way you can do it. You can also use the fact that this one right here was -53 degrees that your calculator gave you, and this one is a half rotation away from it. So you could just do -53 plus 180 and get 127. Either way, remember your angle should be between 90 and 180, okay? So just use that reference angle to help you figure out the actual direction angle. So let's see, okay, so 127 is our direction angle. Then I'm gonna just plug this into that component form where I said you can check it by doing the magnitude of the vector times cosine of the direction angle, and then magnitude times sine of the direction angle. Remember that the magnitude was 10, and now we just found the direction angle to be 127 degrees. So we'll do 10 times cosine of 127 and 10 times sine of 127, and these should give us our components back. So let's go ahead and plug those into the calculator. So we'll do cosine of 127 times 10, and that gives us -6.018. And then we'll do sine of 127 times 10, and that gives us 7.986. And this gives us our two components here. So let me get back to the screen. Okay, so that gave us these two components here, which round to -6 and 8, which were the components of this vector. Okay, so when you're finding direction angles, so just kind of a recap, just make sure, okay, to think about if it's pointing in the first quadrant, this is between 0 and 90 degrees. If it's pointing in the second quadrant, okay, this is between 90 and 180. So you're going to have to subtract this reference angle that you get away from 180 to figure it out. Okay, if it's in the third quadrant, okay, then this one is going to be the reference angle past 180, so you'll have to add the reference angle to 180 to figure that one out. And if it's in the fourth quadrant, okay, whatever this reference angle is, okay, here's 360, okay, just subtract that number from 360 to figure that angle out. So utilize the 180 and 360 and then accounting for your reference angle in each case. So let me do one example that has, so if we get a kickback of a reference angle of, let's say, 17 degrees. Okay, so if your vector is in the first quadrant, then 17 is your answer. Okay, so then this would be 17 degrees. That would be a 17-degree direction angle. If you are in the second quadrant, okay, then this angle here is 17 degrees, but the angle of the actual vector, okay, is 180 minus 17, or 163 degrees. Okay, if you have 17 degrees and your vector is pointing into the third quadrant, again, this angle is 17 degrees. So now we're going to do 180 plus 17 to get that angle. And then if you are in the fourth quadrant, okay, then again, this angle right here is 17 degrees. So fourth quadrant ends at 360, so you would do 360 minus 17 to get this one. Whoops. To get this angle of 343 degrees. Okay, so make sure that you account for those reference angles, because again, tan inverse is going to give you back that reference angle, not the actual full-on direction angle.